The last one of these, question 11, another simultaneous one. We're not told what the first term is. We're told what the second. And the second is AR. And we're told that the second term is 15 over 8. What we're going to do with that is divide both sides by R. Let's say that A is equal to 15 over 8R. The other thing we're told is the sum to infinity. And we know the sum to infinity formula is A over 1 minus R, and that equals 8. And so if I times this up here, I can see that A is 8 lots of 1 minus R. Now both of these equal A, so I'm now going to put these two things equal each other. 15 over 8R equals 8. I'll multiply that out, I think, at the same time. 8 minus 8R. Times the 8R up from the bottom here, we're going to get 64R minus 64R squared, and dragging everything over to one side gives us the quadratic we were looking for. Now, putting that into the calculator and just getting that to solve gives us two answers. R is 5/8 and R is 3/8. And if I then put this into the A over 1 minus R equals 8 one from earlier here, that one there gives me that the first term for that one would be 3, and the first term for that one would be 5. And for the last part of the question, part D, it says taking the smallest value of the two R's, so that's that one there, count n to exceed 9. So usual formula, A over 1 minus R to the n, all over 1 minus R. I'm going to make this equal 7.99. So A is 5, 1 minus 3/8 to the n, all over 1 minus 3/8 equals 7.99. Right, that's rearranging. 7.99 divided by the 5 and times by the 5/8. The value there you get after all of that is 0.99, sorry, just two nines, 99875, just checking that on the calculator. So that makes 3/8 to the power of n have to equal 0.00125. And so we'll find out what n is by doing log base 3/4 of 0.00125. So tapping that on my calculator, I did say 3/8, didn't I say that? And so that gives me that n is equal to 6.81. And so the value of n we're going to want is the first one that exceeds that. So we get n equal 7.